Next is third chapter, steady magnetic field. As I said earlier, first two chapters are related with the electric field. Now third part and fourth chapter is related with the magnetic field. So steady magnetic field, in that chapter there will be a Biot-Savart's law. Up till now in electric field we have studied about we have there was the two theorems was there, that Gauss law was there and Coulomb's law was there. Now in the third chapter there is a Biot-Savart's law. Next is Ampere's law. How it is related, that we will study in that chapter. Next is applications of magnetic flux density. Now we have to apply that Ampere's law in the different application and used to study the different application in the magnetic flux. Magnetic scalar and vector potential, derivations of Biot-Savart's law and Ampere's law based on magnetic potential. As we have seen in the second chapter, there was a electric potential. Similarly, there will be a magnetic potential in the magnetic field also. So you can see in the 3.1 there is a magnetic potential. In the 3.2, force due to the magnetic field, magnetic dipole, classification of the magnetic material and magnetic boundary conditions. So in the 3.2 you will understand that force due to the different magnetic fields, magnetic dipoles, how the dipole is used in the antenna, that we have to see. So the dipole is very basic antenna, and from this dipole antenna the other antennas will be elaborated, or we can say that the application can be used by using this dipole antenna. Next part, that is next topic, that is fourth topic, Maxwell equations and electromagnetic wave propagation. So Maxwell equation, as I said, it is a combination of electric field and the magnetic field. So why was the reason that Maxwell used these electric field theorems and the magnetic field theorems, and how Maxwell is derivated all these made a changes in that electric field theorems and the magnetic field theorems, that elaborated in this chapter. What was happening, that when we were using that electric field, in that electric field there were different theorems we have used, like Coulomb's law and what we have used, Coulomb's law and Gauss law. But problem was that Coulomb's law and the Gauss law was related with static charge, not with a dynamic charge. Means there was not that charge was not moving, it was steady charge, but it is not working in the day-to-day applications, because day-to-day application is time dependent. So if you are going for a time dependent applications, then these theorems should be applied for the time variant systems. So these theorems was improved by this Maxwell. So these equations are all called as a Maxwell equations. Already it was invented by Coulomb's, Gauss, Ampere and Biot-Savart, and Faraday, but Maxwell made them make change in that equations related with the time domain, and now they are with these equations we can use in the time domain also. In the when the time is varying, we can use these equations. So in the 4.1 part, that is Faraday's law. In that Faraday's law, we have to study about the when the Faraday's law without moving charge, and with the Faraday's law we have to see the changes made by the Maxwell equation in the Faraday's law. So displacement current, Maxwell equations in the point form and the integral form, that we have to study. Boundary condition for time varying field, magnetic vector potential. Now see that point, boundary condition for time varying field. What is meant by boundary conditions? So boundary condition means if there will be a two different materials, means you can see that water, if you are looking into the water, there is a two medium, that is air medium and water medium. So there is a two different mediums, and in between these two medium there is a boundary in between water and the air. There will be a boundary of, there is a boundary. So what is the boundary conditions, how the boundary will change, how the things will change when the medium is going to change, so called as a boundary condition. So for time varying field, how to apply this boundary condition, that we have to study in the Maxwell equation. Next, the time varying field for magnetic vector potential. Now you can see that in the electric field also we have studied the electric potential. Then steady magnetic field, we have studied the steady magnetic potential. Now in this Maxwell equation there is a different part, that is different magnetic vector potential, time harmonic fields, and introduction to the concepts of uniform plane waves and Helmholtz equations. So uniform plane waves we have to study. 4.2 part, that is wave propagation in a free space loop and lossless dielectrics, and in a good conductor, reflection and plane waves, Poynting vector, wave power, skin effect, wave polarization, and standing wave ratio. So all these part you should cover in this chapter. In the 4.2 part is totally different, that is wave equation, plane wave equation we have to apply, and the plane wave equation can be removed by using wave equation can be removed by time varying equations we have to apply, and we have to remove that static equations, that is the 4.2 part. Next part, that is transmission line. Now this transmission line part is important for electrical engineer and electronics also engineers, because this transmission line we have to use for transferring that information from one point to the another point for the long distance. So transmission line parameters, transmission line equations, if the charge is moving from one point to the another point for a far distance, then we can use there as a transmission line. We have to find out the input impedance, standing wave ratio. What is standing wave ratio, that we will study when we go for this chapter. Sorry. Tangents on transmission lines. Next part is Smith chart. This Smith chart is, you can see that you can easily in the paper, in the question paper, there is a one part for you that that part will give you 100% marks. So every subject there is a some part available. So in the Smith chart, applications of the Smith chart is finding VSWR, and in that as I said, this every subject there is a part where you can score 100%. So this is the part in the transmission line, this Smith chart part is there for you for to score 100% marks. So there is a chart. Some student initially they feel that it is very difficult part, that Smith chart is, it's look like very difficult, but it is very easy to understand, easy to solve if you once you understand the Smith chart. So this part, fifth chapter, is most of the time came into the last part of this like that syllabus. So most of the student make this part as a optional part, but don't make this as an optional part, because it is the part where you can score 100% in the Smith chart. Next is sixth chapter, last chapter, applications of the electromagnetic. Now this is the very important part, applications of the electromagnetics. electrostatic discharge, materials with a high dielectric constant, graphene, inkjet printer, RF MEMS, and then multi-dielectric system, magnetic leviation, menisters, optical uh, monocircuits, metamaterials, then microstrip lines and characteristics of data cables, RFID. So these all applications are depend on the different Maxwell equations and all other electric field and magnetic field that we have to study. All these application, out of these applications, at least 4 application they will ask in the short note. So don't skip this chapter. At least go through once, because this is very important chapter and there will be a 6 question is totally based on this chapter. So in the question paper, so try to cover this chapter as you can. Next part is textbooks. Which of the textbooks you have to prefer? That you can see Engineering Electromagnetics, William Height and John Ebach. So this book is available in our library. As COVID pandemic is going on, you can't take that uh, uh, the books directly, so I will try to convert that into the digital form, soft copy, and I will send it to you on the WhatsApp group. And second book is Principle of Electromagnetics, Matthew and O. Sadiku. This book is also very important for the problem perspective, because most of the problems are coming in the end semester exam from this book, Sadiku book. If anyone trying to preparing, or anyone is preparing for the GATE exam, then you should go through the StudyQ book, because StudyQ book is problematic is useful for the problematic electromagnetic engineering subject. These are the reference books, so you can refer these books and you can take more and more problems from these books, because as I said, this is problematic subject. More problems are coming. 80% the 80% of the question paper is depend on the problems and derivations, so you should try more and more problems. As I already told you in the network theory also, you should go for this reference books. Next is internal assessment. Internal assessment consists of 2 class tests, 20 marks each, and you have to take an average of the that for this first unit test. There should be a 40% syllabus should cover. In the next part, 40% syllabus should be cover. So that is second unit test. End semester examination of 80 marks. In that 80 marks, there will be 6 questions. That first question is compulsory, and out of 2 to 6, you have to solve 3 questions. So for the 4 questions, there is a 20 marks, total 80 marks. So after 3 or 4 lectures, we will take one online session through the Zoom meeting or Microsoft meeting. So we will do some discussion on that. We will solve more we will try to solve more problems. Those who have query in the lectures, that you can give you can ask me onto that session after 3 or 4 lectures. So we will plan that meeting, and that meeting online we all will meet online, and we will solve the queries which you have faced into your that video lectures. So try more, or try to solve more and more problems that I will give you for the tutorial and assignments. Thank you.